In this example, we have the function x squared, and we want to find f prime, so the derivative. Then we want to find f prime of 2, meaning we're going to take 2, plug it into the derivative, and f prime of -3, we're going to take -3, plug it into the derivative. And we want to also find the equation of the tangent line at the x value of 2. So the definition of the derivative is the limit as h approaches 0 of the difference quotient, so f of x plus h minus f of x all over h. So we want to do x squared, x plus h squared. We want to plug in x plus h into the function x squared. So we're going to have x plus h squared minus f of x, which is going to be minus x squared all over h. And we're not going to deal with this part until after we get the derivative. That's for when we get the derivative, then we plug those values into the derivative. So we have to do this first. So we have x plus h squared. So I'm going to have x plus h times x plus h. One of those scenarios where you're going to start to get this memorized. X times x, x squared. X times h, xh. H times x, xh. H times h, h squared. Combine the like terms, x squared plus 2xh plus h squared. So that is x plus h squared. That's the expansion of x squared, x plus h squared. So we're going to have the limit as h goes to 0 of x plus h squared was x squared plus 2xh plus h squared minus x squared over h. Combine like terms, x squared minus x squared, boom, gone. So the limit as h goes to 0 of 2xh plus h squared over h. And then from here, when we're done simplifying, the only thing we could really do is factor out that h. I have a 2xh, I have an h squared, so h is going to come out of the picture here. So the limit as h goes to 0 of h times 2x plus h over h, because I took out h, so h is gone, h squared becomes h. H is canceled out, which is usually what we want to have happen in this scenario. When we're trying to factor out, we would want this to cancel, because we can't have h equal to 0. So that h in the denominator, something needs to give there. So good, cancels out. So then we're left with the limits as h goes to 0 of 2x plus h. Now that we've simplified it all down, now we evaluate the limit as h goes to 0. So I'm going to replace h with 0 now. So 2x plus 0, which is just 2x. So that means f prime of x is equal to 2x. So f prime of x is equal to 2x. After all of that process, we got down to 2x. So there's a couple more parts to this question. It says f prime of 2, f prime of -3. So that means we're going to take f prime of 2 and f prime of 3. So I'm going to plug in 2 into my derivative. So this is going to be 2 times 2. 2 times 2 is 4. Then I want to do the same thing with 3. So 2 times 3, plugging in 3 into my derivative. 2 times 3 is 6. Okay, and then the last part to this problem is find an equation of the tangent line. Find the equation of the tangent line at a specific point of x equal to 2. So we want to find an equation of the tangent line. So we're going to need to use point slope. Point slope, in case you don't have that ready to go in your back pocket, y minus y1 equals the slope times x minus x1. Point slope. Y minus y1 equals the slope times x minus x1. All right, so let's go through what we have. slope. And we want to use the slope of the x value. So we're trying to find the equation of the tangent line at x equal to 2. So we want to use the slope at x equal to 2. This is what this process was right here. F prime of 2 is the slope at the x value of 2 because the derivative is the slope of the tangent line. So this tells us that the slope at the x value of 2 is 4. So our m value here is going to be 4. And x and in the point slope, y is locked in stone, and then y1 is what we have to get, equal to m, which we decided is 4, because the slope of the tangent line, derivative, 2 times 2 is 4, x, and then we have to get x1. Or we have x1, which is 2. The only thing we're really missing is just the y value that corresponds with 2. So we're going to plug in 2 into our function. So we're going to do f of 2, and that's going to be 2 squared, which is 4. So we're going to have 2, 4. And we want the original function, don't plug in 2 into the derivative, because the derivative is the slope of the tangent line. So don't plug in 2 thinking, oh, I'm going to get the y value because I'm going to plug in 2. And you want to go back to the original function. So y minus y1 equals the slope of 4 minus our x1 of 2. And then we just have some simplifying here, some algebra. 4 times x is 4x, 4 times negative 2 is negative 8. So y minus 4 equals 4x minus 8. And then we just solve, because let's get in slope-intercept form. I don't think the directions are specifying. Let's just get into slope-intercept, because that's typically how we want this to look. So I'm going to have y equals 4x negative 8 plus 4 is negative 4. And there is our equation. The tangent line at x equal to 2.